Hey, this is Presh Talwalkar. You visit a shrine that has 3 temples in a magical pond. Before you visit a temple, you have to swim in the pond. The path you take involves swimming in the pond to get to the first temple, swimming in the pond to get to the second temple, and then swimming in the pond to get to the third temple. Each time you swim in the pond, the number of flowers you are carrying magically triples. You place an equal number of flowers at each temple you visit, and at the very end, you have no flowers remaining. The problem is, what is the least number of flowers you could have started with? To be specific, you start with a positive number of flowers and you place a whole number of flowers at each temple. Can you figure it out? Give this problem a try, and when you're ready, keep watching the video for the solution. We will solve the problem algebraically. Imagine you start with X flowers and you leave Y flowers at each temple. Let's keep track of how many flowers you have at each part of the trip. You start out with X flowers. When you swim in the pond, the number of flowers you have triples to 3x. You then leave Y flowers at the first temple, which leaves you with 3x minus Y flowers. You then swim in the pond, which triples the number of flowers you have to 9x minus 3y. You'll leave Y flowers at the second temple, which leaves you with 9x minus 4y flowers. You then swim in the pond once more, which triples the number of flowers you have to 27x minus 12y. You leave Y flowers at the third temple, and you have 27x minus 13y flowers. Of course, at the very end, you have no flowers. This leads to the equation 27x minus 13y equals 0. So x equals 13 divided by 27 times y. We need the number of flowers you place to be a whole number. The least value for y would be 27, which means that you started with 13 flowers. In fact, this is the solution. We will verify this numerically. So if we start out with 13 flowers, we swim in the pond and that triples to 39. We then leave 27 flowers at the first temple, which leaves us with 12 flowers. This triples to be 36. We leave 27 flowers at the second temple, which leaves us with 9 flowers. This triples when we swim in the pond to be 27. We then leave those 27 flowers at the final temple, which leaves us with 0 flowers. So that's the solution to this problem. Now, interestingly enough, the kind of mathematics involved in this problem can actually be applied to financial products. We can reinterpret the problem as an example of an annuity, which is a financial instrument that has equal payments at regular intervals. The number of flowers we place at each temple, Y flowers, could be considered having equal payments at regular intervals. Imagine we take a loan out for X dollars. Every year we pay off Y dollars of the loan, but each year the amount of debt that we have remaining triples. We have an interest rate of 200%. If we had this kind of problem, and each temple we imagine visiting one temple in a year, this would exactly lead us to the same algebraic problem of paying off a debt in 3 years, in which we have an equal payment of Y every year, and the outstanding debt triples. At the very end, we would want our debt to be 0. The mathematics of annuities can be generalized. So let's imagine we didn't know anything about this problem and we just approached it as an annuity. Here's how it would work in terms of time intervals. We start out at the first interval where we take a loan of X dollars. After 1 year, our loan will increase by an outstanding loan rate, an interest rate of I%. So we multiply X times 1 plus I%. After the first year, we make a fixed payment of Y dollars, which decreases the balance of our outstanding loan by Y dollars. Now comes the part where in the second year, we have an interest on the amount of loan that's remaining. So we multiply these amounts by 1 plus I. This is like dipping into the pond and having everything magically grow by 1 plus I. So we multiply 1 plus I times both terms, and this is what we end up with. We then pay an amount Y, and we subtract that on the outstanding loan, which then gets increased by 1 plus I in the next period. So this pattern can continue, and we can imagine paying this off until n years. We end up with a formula that involves a geometric series. We then have one final payment of Y, which then changes the subscript on the geometric series. And we now want our loan to be paid off in n years. So we need this to be equal to 0. We can simplify this formula by using the sum of a geometric series up to n minus 1. This is the formula that we end up with. And this can be used for any annuity where you take out X dollars, you have an interest rate of I, and you have n periods. In the magical pond, we started out, we had 3 different temples, so we had 3 different periods, and between each temple we had to swim in the pond, and the number of flowers we had tripled, which is an interest rate of 200%. We can substitute these values into our annuity formula, and notice we end up with exactly the same equation of 27x minus 13y equals 0. This is an alternate way of solving the problem, and it's a way to see how this problem relates to financial products. Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like this video, please check out my books. There are links in the video description.